bits of information you need for a box plot: the minimum and the maximum, the lower quartile and the upper quartile, and the median. What I do is when I see this information, I will plot it. I'll put little markers on the axes here. So 11, 28, 37, 42, and 51. Then I'll draw a line from right along this centre, this dark centre line here, from the minimum to the maximum. Now, I'll do it really lightly because I want to remove something in the middle. I'm going to put lines, they don't need to be this long, but make them even, it looks prettier. Then I've got these three in the centre. So I've got these three, and what I'm going to do is mark those 3 points on this line. And that's going to give me the guide to draw this box in. Up to that line. And this one just here. And I need the median line. So this is a representation of my data. I'm actually going to draw it in pen. Now I'm happy with it. You don't technically need to do that as long as you've drawn it correctly. In fact, if you did put it in by pen and you realise afterwards you've got it wrong, then that's a problem. You'd have to redo it. But I'm putting it in pen so you can see it clearly. So what we have plotted is the minimum and the maximum points, and that's where our lines end, and we put these thin lines here. Between the lower quartile and the upper quartile, we draw a box. And then within that box, we put a line where the median is. Now, with this one here, we haven't quite got all the information we need. We've got the median, we've got the quartiles, and we've got the maximum, but we actually need the minimum. But we've got the range. So the minimum is the maximum subtract the range. I'm going to go with it being calculator questions so my brain doesn't ache too much. 84. I could have done that in my head, guys. Okay, so 84 here. So now we can plot it. Again, I'll use a pencil or plot 84. Now, this is not a nice scale here. So 84 is actually 2 boxes along. Then I do my 110. 132, that's 130, and 2 is just there. 162 is just there. 185. Now, that's 190, so actually 185 is right in the centre there. So again, I'm going to take the maximum up to this line and the minimum up to this line. In fact, you could put all of them up, to be honest. 110 here, 130 here, 150. I quite like that way of doing it, because this way I can just go up to those lines. So this is upper quartile to maximum. This one is lower quartile to minimum. And that's my maximum minimum. And then what I need to do is draw my box between these lines. Just be careful you are indeed drawing them on the right lines, drawing them straight. I mean, technically you don't need a ruler, but your lines need to be straight if you're not using a ruler. I'd obviously prefer to use a ruler. Okay, that was draw better this time. So minimum, maximum, and we had to work out the minimum because we only had the range. Now, I think this question is trying to fool you, and you just put all of that information in, which case this would be wrong in this place here. So you'd have got that second point for knowing and spotting that says range instead of minimum. Okay, but what if we have a box plot with no table in it? We need to remember what key bits of information we need. we need the minimum, we need the maximum, we need the median, we need the lower quartile, and we need the upper quartile. Okay, keep its information. This data is in ascending order. So that bit is easy. We're then looking at the median, and so we can cross these off. Oh, wait, 2, 3, 4, 5, 6, 7. The median is 60. Then we're looking at the lower quartile and the upper quartile. The lower quartile we work out by going in from here, 2, 3, and it is between, no, it's not, it is 55, isn't it? We've got, from here, we're looking at the middle one here. So we don't include the 60. We go 1, 2, 3, and the lower quartile is actually 55. And we do the same here. So we're going in from here, 1, 2, 3, and it is 64. And then these are the points that we're plotting. Let me just go back through that again. If I want the upper quartile, I need to find the middle piece of data within these numbers. So that's 1, that's 2, that's 3, and then this is where our upper quartile is. Right, so I'm going to plot these again. 52, what are we doing? Oh, that's 55, so this is 1, this is 2, so this is 52. 55, yes. 60, yeah. 64 is just there. 75 is easier. Right, I'm going to plot these onto my middle line. 52, 55, 60, 64, and 75. Right, I'm going to join. I'm going to draw a line there and a line all the way up to this one. Let me just check 64. Yeah, we're at 64. Quite a long line. Still works. And that's my box plot. We'll do the same with this one. Okay, data again is in ascending order, just like when you've ever done median before, we need to check that. So this one is our minimum, this is our maximum. We're then looking at our middle one, 69, and then we're looking at these 5 pieces of data here, and we're looking at the middle one there, which is our 59. And the same here, sorry, that's our 69 piece of data, and there's our 5, 80. So plotting those, 48, 59, 69, 80, 91. I'm going to transfer those to the middle line. And voila. Okay. So this one is more a problem-solving question. It's 2 points for plotting, but it's also 2 points for writing some words down here as well. We're going to compare the distribution. That's what a box plot is. It's a way of comparing two sets of data. Okay, so that is the, oh, let's make this line longer as well. That's my box plot for this piece of information here. And what it says is there are also tomato plants in Nigel's garden. And so this is the box plot of those tomato plants. And what it's wanting us to do is to compare the distribution of the heights of Maggie's plants with the distribution of height of Nigel's plants. So these are Nigel's, these are Maggie's, and we've got to compare the heights. Now we do that with statements. We have to hit certain types of things. We can compare the different things. So we've got the median, for instance. So we can say that the median height of Maggie's tomatoes is greater on average, therefore they're taller. So on average, they're taller. So we want to talk about the median height of Maggie's That's no good, is it? This is what I've just written. Median height of Maggie's plants is greater than Nigel's, therefore they are taller on average. What we also want to compare is the spread. So the spread is the length of that interquartile range. So the interquartile range here is 42 subtract 27, which is 15. So Maggie's the interquartile range is 15. And with Nigel's, you can see it's larger. 40 through to, what's that, 16? 24. So this is the we call it the IQR, the interquartile range. So we're talking about the distribution, the spread. So the key words here are median height, means that they are greater on average. Okay, so they're taller on average. Here, we're talking about the interquartile range, and that's about the spread. Okay, so this is about the average height, and this is about the spread. We need both of those marks. If there's a 2-mark question, we need to talk about the median and the interquartile range. You could talk about maximum minimum. That's not really what's asked for here. It talks about the distribution of heights. And because it is about the distribution, we're looking at the average height and the spread. And these are the two that give us that information.